Any word of any jets from Justin today?
No, not yet. Got my phone out so he can give me forewarning. They're coming.
Good morning, good afternoon, everyone. We're just going to give this a minute for everybody to join. They may be coming from other meetings or other discussions, so we'll just give it a second. Got about 21 people. We're expecting a little bit over 100. So again, we're going to give this a couple minutes for those who are just joining. Again, good morning and good afternoon, depending on where you are in the world. If everybody wants to comment on where you are located and where you're tuning in from, that would be cool for us to have visibility into where our audience is today. So if you want to add that to the comments. Tallahassee, Florida, Chicago, the Netherlands.
Wow.
Wow. Thank you. Spain, Nashua, New Hampshire, Hamburg, Germany. We're up to about 25 folks. Again, we're expecting, we had 100 registrants. South Africa. So again, we're just going to give it a couple minutes. Florida, I'm in St. Petersburg, Florida. Hyderabad, India. Get me some chicken biryani.
One of my personal
Honolulu.
favorites.
Hawaii, you're 6 hours behind. So somebody got up early today to hear Kristi and Gerald and David share their technical knowledge. 6 a.m. in Hawaii.
Yeah.
Hyderabad's, well, 10 or 11 hours ahead this time of year. So that's midnight for somebody. Maybe 11:30. It's hard to keep track of the time and the time change. Okay, what do we think? We got about 28 people. We'll give it another minute, maybe two. 29 people. Anybody who's just joining, if you want to share your location, we find that fun. Okay, great, everybody. We're going to go ahead and kick off the presentation. My name is Peter Katrubis. I'm your host for today's Analytic and Data TechCast, which is going to begin following this brief introduction. I'm an Oracle Analytics practitioner and a longtime associate of the Analytics and Data Oracle community, and I currently serve on the board of directors as the marketing lead. Today's TechCast is going to be a great presentation by Gerald Dildine and Christine Price, and it's going to be on mapping the way to transportation safety. So after that, we're going to have a brief Q&A. And slide, please. We've got some helpful links here for Analytics and Data Oracle user community. Please make note and check it out. So we've got some future TechCasts coming up. Most notably, easily build analytic applications using APEX and Analytic Views on August 8th. Our favorite features of Oracle Analytics Cloud for August 22nd, which is a reoccurring theme where we always try to keep up with the latest feature functions of Oracle Analytics Cloud. So look for that one periodically. And then we've had some previous TechCasts which you may be interested in. Our most recent one with advancements in Essbase, federated partitioning, autonomous data warehousing integration, long live Essbase. That was on May 23rd. May 14th, we had Welcome to Analytics Data Oracle User Community, which was all about getting involved and volunteering. If anybody here is interested, check that out. Also on May 9th, we had Leveraging OAC for Analytics Warehousing. All those are available on our website for your convenient self-service. Slide, please. We've got a lot of cool merchandise. So all the cool kids are buying this stuff, putting it on their desk, and if you're interested, that stuff's all available. So check it out on our website. Next. Ways to connect. There's a lot of ways to connect with us. We try to make it easy for your favorite flavor of channel connections. So check out either our direct website, check us out on Slack, LinkedIn, Facebook, Twitter or X, whatever you want to call it. And then again, all these TechCasts and stuff are promoted on YouTube. So you can consume that content either directly from our website and our TechCast webpage, or you can go to YouTube. Many ways to access this content. Next, please. So without further ado, we're going to jump into mapping the way to transportation safety. Kristi, Gerald, David, all yours.
Hey, good morning, good afternoon to everyone. We're coming to you from Central California, so it's about 9 a.m. here. My name is Kristi Price, and I am the Marketing Director at ITIS Corporation. And with me today, we have Gerald Dildine, who's President and CEO. Jerry will be here to answer some of the more technical questions, and of course, David Lapp with Oracle as well. Just a little overview of our company. So ITIS Corporation, ITIS is an acronym that stands for Integrated Transportation Information Solutions. So we go by ITIS. We're a software and engineering consulting firm with more than 20 years of experience. A lot of our senior programmers have more than 30 years of experience serving the needs of transportation and safety industry professionals. Our flagship software that we develop is called the Safety Portal, and it is an enterprise safety management system. And currently, we're up to just about 30 different apps that are contained within the Safety Portal. And so the different apps handle things like data analysis, data management, and we've got some advanced decision support tools that really help with the operational work in a Department of Transportation or a Department of Public Safety, most often found in the state and local government level. I mentioned we've been around for quite a while, so you can see some of our current clients and clients we've worked with in the past on here. Today we're going to be showing some demonstrations, and what you'll see is really what we have installed with the Wyoming Department of Transportation. They've been longtime loyal clients of ours for probably getting close to 18 years now. But in general, our customers are typically traffic safety engineers and other roadway safety professionals in the highway safety department. So we're talking about roads here. So the engineers are managers that oversee the planning and management of roadway safety programs. So they're analyzing traffic collisions, and they're maintaining the public road network, including things like the linear referencing system, intersection inventories, and physical asset inventories like road signs, guardrails, etc. They're also keeping track of roadway features and characteristics for all of the public roads across the whole state. So the decisions that these engineers and managers are making are really determining what improvements are made to our public roads in order to reach this nationally mandated lofty goal of reaching 0 fatalities with car crashes. So this reaching 0 fatalities with car crashes is a really bold, comprehensive plan to improve roadway safety. And on the screen here, you'll see a quote from our U.S. Secretary of Transportation. It's become a real priority, thankfully, and there's been quite a bit of funding released to really improve the safety of our roads to get those fatalities down. So what is roadway safety? In our case, we're talking about the relationship between the characteristics of a road and the occurrence of crashes on that road. So typically roadway safety studies answer questions like, how do we determine where and what to do to the roads to make them safer? So I mentioned our flagship product, the Safety Portal. Really, it's designed so that it's the most comprehensive set of specialized tools available in the industry, and it's designed to help those traffic engineers answer those very questions. How do we make the road safer? How do we determine where we need to make changes, and what changes do we need to make? So here you'll see kind of a little graphic. That's what our safety portal looks like. You'll see it in a couple of minutes. We'll show you a demonstration, but really it's an intuitive map-based and really easy to use system. And I mentioned it contains just about 30 apps now. So a handful of the apps are really geared toward data analysis and then data management. I mentioned quite a few different inventories that we have to keep track of for traffic safety and roads. A big one is predictive modeling. So we're predicting how severe future crashes might be, or how we can reduce the severity of those crashes by applying certain remedies to the road. So these decision support tools really help engineers make the best safety improvement and business decisions that they can. So bottom line is really the software makes the daily operations of a safety department run smoothly, makes the engineer's job easier, and really the maps and spatial analysis provide a complete picture and give deeper insights into making those good business decisions. And here we have a quote from one of our clients at Wyoming Department of Transportation. So they've really embraced the safety portal and use it heavily every single day. So by applying the predictive modeling and analytics and providing them with easy to use dashboards, all transportation agencies can gain insights to take action to make the most of the available resources. They're all allotted a certain budget every year, and they have to stick within that budget for man hours and physical improvements to the roadways. So the software can really help them make the best decisions and reduce the severity of future crashes. So just a little bit of background. I don't know if you guys are really familiar with traffic safety and roadway safety, other than obviously experience driving a car yourself, but really we're talking about what are the causal factors of crashes. So we have behavioral reasons like texting while driving or speeding, driving drunk, vehicle characteristics, like are they big commercial vehicles or just passenger cars, traffic volumes, how much traffic is consistently traveling on the same section of road, and then of course, excuse me, the characteristics of the roadway itself, like is it a really steep, windy road? Does it have guardrails, or, is it 2 lanes, 4 lanes, things like that. So the road characteristics and traffic volume really significantly affect crash frequency. So our work involves analyzing safety from the road characteristics and traffic volumes perspective. So what happens when we don't have enough historical data to really understand what's happening on a road? Well, really the problem is that engineers can make mistakes. So what happens when there's sparse data? Well, it can hide road safety problems. So in some cases, there's not enough observation data or actual crashes that have happened historically. So there's not enough observation data to determine the extent of the roadway safety flaws. So there are large numbers of severe crashes that can occur on really low volume roads, for instance, traffic volume, I mean. Then we can also have, excuse me, I went forward too much. Then we can also have spikes in the data history, and we can overrepresent safety problems on a road. So data can spike from certain events, but then return back to a normal level. So these spikes sort of artificially exaggerate a problem. So that effect you probably learned in college is the regression to the mean. So I'm not going to get too much into the math or anything here, but these are some screenshots you can see on here. You might recognize the APEX interface here in the background, Oracle APEX. Some really amazing charting tools. So what we're looking at right here is an example of the predictive model in action. So this screen is showing historical crashes along the roadway. So on the y-axis, you have got the number of crashes, and the x-axis, as you're going along, those numbers you see at the bottom, those are the mile markers on the roadway. So you can see, you know, where there are some spaces where there have been no accidents, like I don't know if you guys can see it well enough, but 44.2, 44.4, along those miles of road, there haven't been any crashes yet. So our predictive model, you'll see here in this yellow line, shows what predicted crashes could happen here, even though they haven't happened yet. This is where they could happen. And then this next slide right here are expected crashes. So this is an example of the model showing the crashes with weights applied. So what this is doing right here is making use of a combination of weighted 5-year crash history, and then it's enhanced by considering really site-specific things about the road itself. So it adjusts the model, and this solution ends up putting more weight on the observation data where it exists, and then more weight on model data where observation data doesn't exist or where a crash hasn't happened yet. So why is predictive modeling important? And basically, in summary, it creates a more complete representative data fabric. So it helps traffic engineers to diagnose problem areas along the roadway. And we also, use this model to help calculate cost benefit values and highlight project trade-offs. There's always a couple options or different treatments that they can apply to a section of roadway to make it safer. So they can see in charts and graphs to help visually make those decisions kind of pop out to the engineers. So basically, it leads to an overall increase in efficiencies in identifying problem areas and potential treatments, is what we call the improvements to the roadway, as well as tracking the life cycle of the safety improvement projects. So when this model is deployed, it does quite a few things, but some of them are really important, are identifying high injury network locations. So what that means is the road network, the whole collection of roads, where are the places on the roads where a level of severe crashes has either already occurred or could occur in the future. We calculate the potential treatment benefits for that location, so we can actually use the computer model to apply a treatment, and we get a scoring system back immediately that we can see on the screen. Okay, well, it looks like this safety index score can raise or lower by a certain amount if we apply this treatment. We can also calculate the life cycle cost of that treatment or the improvement to the road, which leads to project efficiency in comparing cumulative cost to cumulative benefits. And that's actually what you see on your screen right now. So again, this is APEX right here. And on that y-axis, we've got the cumulative benefits. And then on the x-axis, we have the cumulative life cycle costs. So what this does is the engineers can just look at the screen that we have here, and anything that they see over on the left-hand side of the screen, those are all projects that have a low cost, and as they move up that y-axis, they have a higher benefit, or they're going to impact safety more and make the roads more safe. And then, so of course, as we move out across to the right there, those are projects that are more expensive, but typically do provide a great benefit. So for someone having to manage finances, we have this bucket of money that we can spend and we only have 1 year to do it. Which projects can we take? So in the screenshot, you'll see there we're mousing over one of the little dots there. And so you can see some details in that screen. That's one of the potential plans that a safety engineer has put in for a specific section of roadway. And we're able to see the impact on the safety scoring and how much it'll cost, how long it'll take, and quite a few other attributes to that treatment. Pause there if Jerry, if you wanted to add anything.
Well, this isn't a map, but this is a very important graph that we use quite commonly, and most of our clients find this to be one of the most important graphs, and it's one of the best at showing you what I like to say is the biggest bang for the buck. So if you look at the shape of the curve, you can see on the far left very quickly the benefits rising without the cost going up, and then at the far right you see those are the most expensive projects, and the benefit isn't rising that much. So as Kristi was mentioning, in budgeting considerations, if you want to infuse potentially the next project that you plan for, you can easily pick out which one is going to provide you the most effective use of your funds. So yeah, this particular type of graph that we use APEX to generate is very useful for management decisions.
Okay, so now moving on to how we use Oracle with our enterprise safety management system. So how do we build this system? Well, we make use of several Oracle products. So some of them include Oracle Database, APEX, Map Viewer, Spatial Studio, and then also integrating with Mapbox or MapLibre. So we use these products as our primary platform for building these spatially oriented business applications. And
Kristi,
why? Yeah.
I'm not sure. Maybe I should raise a thumb or something, but yeah, I want to mention here before we go too much further. So everything you're seeing today is based on the Oracle stack, with the exception of some of the maybe some of the Mapbox stuff. So, but the Mapbox and MapLibre are what Oracle recommends interfacing with their Spatial Studio. So even that is kind of by recommendation from that group. And I want to say that recent advance in a database and Spatial Studio with it, we just have fallen in love with this stack. I think you're going to see some of the things in Spatial Studio make it extremely powerful next generation tool for handling mapping kinds of things. And we hope to give you some tips or show you some things that bring some of those nice new advantages out. We use all the different spatial tools available in the marketplace, but we're very much an Oracle shop, and we're very fond of Spatial Studio for the things that it brings to bear.
Yep.
Okay, Kristi.
Well, so that's actually one of my next points is why do we use the Oracle Spatial and Graph products? And well, as I mentioned before, our developers have been around for a while, and so has Oracle Spatial. So it's a long-standing resource for the database-centric spatial data handling. So we found Oracle products to continue to evolve and improve and match or exceed any of the technological advancements of other complementary solutions. So currently we have a version of our safety portal running in Wyoming on premises, and then our newest safety portal version 3 that is launching as we speak actually is running on OCI. So we mentioned using Oracle Spatial Studio. Spatial Studio is an really evolving server software that's used for managing and deploying the spatial applications without having to write a lot of code. So for us, it's a follow-on to Oracle's earlier Map Viewer software, and Map Viewer requires a lot of JavaScript development. So with Spatial Studio, we use the SQL that it generates as a starting point for filtering data and performing data aggregations and transformations and some of the calculations that we do. And then the data sets and query results we expose as REST endpoints that we use in developing all of the different spatial applications. So yeah, as I mentioned, we've used the Oracle Map Viewer software for years, and we're currently taking a hybrid approach to development. And we use the low-code Spatial Studio whenever we can because it is a huge time saver to us. So that's a nice benefit. So I'm going to go over a couple of the benefits here really quick. So we've got 4 of them here, and really one of the best benefit for us is the use of the vector map tiles, and then integration capabilities, as Jerry mentioned, with Mapbox and MapLibre, because we are heavy on the maps. Integration with Oracle database and autonomous database, and then of course our integrations with APEX through the RESTful services and ORDs. So Spatial Studio creates and caches vector tiles, and that wasn't possible previously with Map Viewer, so this is a huge advantage for us. We get much better performance compared to previous capabilities with the raster graphic backgrounds. So we can now display 5 to 10 times the number of features in the same amount of time that we previously could. For example, our previous displays, as I mentioned, were raster based, and the display updates were kind of slow, and we'd have problems with the raster tiles breaking because we have such large maps with a lot of data all over the state. So overall, the performance quality kind of suffered. But now with Spatial Studio, we can display more than 200,000 crashes, and each one of those crashes has about 100 attributes attached to it. And we only need just a couple seconds to do that. So before we'd need 30 plus seconds to display 25,000 crashes. And we'll show you here in just a minute how quickly we can display 200,000. So Mapbox provides an advanced and robust JavaScript client front end for designing the attractive map displays that you'll see. So Mapbox is really well integrated, and we do a lot of mapping. There's a simple version that's included, but we connect with a token and do some more advanced displays. But it's got full integration with the Oracle database, very important to us, and APEX, of course. And APEX is what our clients see on the front end. So after we've created our displays and linked them to the Spatial Studio, we can pull them into APEX, into map regions, and show them there for the clients. And we're going to move on here. This is a screenshot of the Spatial Studio interface where we can display that in APEX, the layers that result from filters that we set inside of Spatial Studio. I'll show you an example in a minute of those. Some of our key technical approaches are that we use Oracle database to add geometry to the database table, and then we add those tables into Spatial Studio, and then we test the display inside of Spatial Studio. So it's really quick. As soon as we make that connection, we can see our routes coming in, our intersections and crash points. And then, as I mentioned, we add the map to APEX. And then once it's in APEX, our end users are doing things like, changing the length of a route, or changing the location of a point of interest like a school or something. And we're using the ORDs to generate the GeoJSON to handle those edits. So real quick, how we do that is that we can set a starting point like a GPS coordinate for the map display. We can add other necessary data layers like the crash locations, intersections, road lines, etc. We can determine the symbology. So for example, you see the red line there representing the segment of the route that we're studying. You can change the line thickness, size, color, all of that. I don't see it in this screenshot, but there are also interactive map legends, and that legend can be used to filter the data that you're seeing. So you can click on the little icon on the legend and turn layers on and off. You also can change the map background. So you probably recognize that as a satellite view. I'll show you some others in a minute, but being able to change that map background is really important to us in different use cases. So we can also add some navigation to it. You might see down there at the bottom, we have a move to start, move to end, and move to center button. So that can jump and recenter the map on your page so you can really quickly get to the very beginning of a route. You don't have to sit there and pan and pan and pan across the map. It just gets you there immediately. So we use the vector tiles for rapid display of the base maps and providing those different base map choices that I mentioned, and also that we're using ORDs and GeoJSON for editing line features. What you see right there is an example of an intersection leg, and you'll see a quick little video clip of how that's edited. It's really simple, drag and drop interface, so our end users don't have to be programmers to be able to do this. Excuse me. We use Spatial Studio to handle the feature management, token management, and vector tiles. And so our approach is to add the features using the tables in the Oracle database. So again, these are things like crashes and maybe polygon boundaries for cities, counties, or a state. And then of course, point features like intersections or points of interest. And when we say that in safety, an example is maybe a school. They want to know how many crashes are happening within a distance of a school, or how many crashes are happening within a threshold distance of an establishment that serves alcohol. So I will be showing you a demonstration, but this is just a quick screenshot example here of some linear features in Spatial Studio. And as soon as we make that connection with the database, we can instantly see our routes pop in very quickly. I had talked about filtering that we can do in Spatial Studio. So this is right here is an example of crashes that are occurring within a half-mile of an elementary school. So these are all of those crashes there. And excuse me, these are some example use cases, and I'm gonna go kind of quick through here because you'll actually get to see those in person. But I mentioned the base map background. So for certain cases, trying to locate a crash on a map or trying to locate an intersection properly, especially in Wyoming, there are a lot of dirt roads. So sometimes the satellite view is not the most helpful, or sometimes it is, and you kind of toggle back and forth between the dark background, light background, and the satellite view. Customers really like that. So that is a really great feature that is offered by the Spatial Studio. Here we are looking at an example of a school and editing a point location. And I'm gonna try and get this video to play here.
To move a one point on a map, to edit it, all you simply have to do is grab it, slide it to the location you're interested in. Once doing it, you simply apply changes. And the point is moved.
And that's how simple it is, excuse me, on the front end to edit a point. So you might wonder with traffic safety, why do we care where school is? Well, public safety offices are really often concerned with the number and severity of crashes that are occurring around schools. And so analysis of these locations can really be used to help define something that they call the safe routes to schools. So if a child is walking to school, which roads should they avoid? Where should they turn to get to the school? So locating these point features, we are typically starting with either like a GPS coordinate or even a street address. And you saw how easy it is to just grab a hold of that dot representing the school and move it out to the street where the school actually is. And then they continue on with analysis from there. This is an example of a linear feature. So we'll show a quick little video of how to edit this. Maybe. Not for some reason. Well, it's not playing for some reason, but I will tell you that little red dot that you see at the north, you can just go ahead and grab that and pull it down. And then the dot that's more on the southern end of the screen, you can grab that and pull that up if you wanted to shorten that linear segment. And as you do so, then, excuse me, over there on the left-hand side of the screen, those are attributes about that linear feature. You'll see the measures on the beginning and ending update, and you just drag and then hit apply, and there we go. And next we have an example here. This is our collision diagrams application. This is just an example of how we can combine really complex point features and advanced symbology. So you see all those little arrows and kind of angles and squiggles there. Those are representative of excuse me, different types of crashes that are occurring around intersections. And so engineers are using those. So those aren't common symbols that you would find in a map, but we are able to use Spatial Studio and advanced Mapbox features to be able to bring in custom vector graphics like that.
Kristi?
So, yep.
So can you perhaps back up a couple slides where you had the linear reference to feature?
Yep.
Yeah, so there was a question I thought I'd just kind of verbally answer if that's okay.
Mm-hmm.
So the question was, are the vector graphics dynamically built? And one thing I want to make real clear on here, a couple things. So we use both the vector tiles and we use GeoJSON. So we use GeoJSON whenever we want to do any interactive edit. It's real easy to create GeoJSON features using ORDs in APEX. So we make use of that whenever we're going to perform edits. So what you're seeing here is that's a GeoJSON feature that we have in the red there, and along with the endpoints. And then the vector tiles for stuff that we have cached. It caches it in the server, so it's really, really fast. When we make use of the API so that whenever we do an edit, our system knows when we're doing an edit, and it'll do a refresh, and it'll instantaneously update the cached data that's on the server. So it's a combination to get the dynamic results. So we don't have to update the cache unless we're updating it. But whenever we update it, we do hit a refresh, and then whenever you view that, no matter what map view, it gets updated dynamically. So hopefully that answers that question. Okay, Kristi, thank you.
Yep. Okay, so the collision diagrams, I just mentioned some of those different types of symbology that we can use. So the SVG or the vector graphics are really helpful here. And we can do custom positioning on the screen. With collision diagrams, for instance, the quadrants of the screen that these icons show up in indicates the direction of travel for the vehicle. So again, that's another really important thing for the safety engineers. Roundabouts. Roundabouts are really complex feature and feature collections. So we roundabouts consist of multiple parts, including both point and linear features. So we can go from really simple lines and points to very complex collections of features and points. Each one of those entrances and exits to the roundabout has several pieces to it, and they're all important for different types of analysis. We had talked about the legacy raster version that we had used. So there on the left-hand side of the screen, you're looking at the same roundabout there. The right-hand side is the new vector-based version. So you see how all those colors change there. The engineers are interested in where collisions are occurring, if they're occurring when someone is entering the roundabout, when they're trying to change lanes to get out of the roundabout, etc. So this is a huge step up for us and for our clients here. And then just another screenshot example of this legacy versus the newer version here. I'm going to show you this demo, but real quick, I'll just say that the safety gazetteer I'm about to show you, there's some predefined queries producing these visualizations. So there are things that engineers are regularly interested in. They want to know the same things every day. So we can set up some predefined queries for that, so they don't have to custom build a query. And then we also have a new tool that we're just starting to use that has been added to APEX. Well, no, David, you might know. I'm not sure exactly how new, but I do know it's a newer feature. So we have various approaches that we use to answer questions on the fly. And so this is one of these examples. So I'm going to go ahead and show you that. Bear with me just a second.
Yeah, so while she's getting ready there. Yeah, so we oftentimes, our clients want to slice and dice the data in different ways. And no matter how many ways we come up with being able to filter the data and review, look at the data, they're always asking for something new. And APEX has come out with a number of new search mechanisms that are quite helpful. So we showed you there the faceted search. We're implementing that, and also we'll be soon implementing the smart filters approach for map data. What you probably won't see is I think we're one of the first ones to implement those things tied to a map, and they work quite well, and they're very, very useful for people using map data.
Are you able to see my screen?
Yeah.
Okay.
Looks great.
So this is just our welcome screen. Basically, when you come into the safety portal, I mentioned we have 30 plus apps. So these are the APEX cards that will open up each one of those apps. But right now we're going to take a look at map views. And we'll take a look at our safety gazetteer. I'm gonna collapse. This is another cool feature. You can kind of collapse and change some of these windows. It's really necessary when you're dealing with maps. So what you see there, this kind of honeycomb look, is the new H3 hexagons here. So you might be more familiar with a heat map, but we find this to be a lot more useful because they're more defined boundaries as opposed to the older heat maps that have sort of that gradient fade out effect. And so right now, you notice I have this map layer control right here. So I've turned on all of the crashes, and it has already loaded. You saw how quickly I opened that. It's already loaded. This is just shy of 200,000 crashes. And again, each one of those crashes has about 100 attributes attached to it. So I'm going to zoom in on Cheyenne, which is Wyoming's most populous city. So you can kind of, actually, I'll pan around here. You can kind of see, figure out where the roads are just by where all the crashes are occurring. But I'll keep zooming in here and you'll see these change size. And then when we get to a certain level, it actually does turn to the point of the crashes. each one of these dots represents a crash. Some of them are stacked on top of each other because multiple crashes happen in the same place. But we can click on them, and this is an example of some of the attributes that come back with each one of these crashes. So incredibly, incredibly fast. That would have, I don't even know if we would have ever been able to display 200,000 crashes. The system probably would have bogged down. And now that is just almost instant for us. So I have my crashes turned on. So all of the crashes, they're all turned on, but I mentioned that we have some predefined queries. So over here on this side, you'll see some of the areas that engineers are commonly interested in. They want to know how severe are the crashes that are happening. So over here, you can see in this legend, we have our fatal crashes, serious, minor injury, and property damage only kind of crashes. So you can zoom out and you can sort of get a view in this area. Each one of these, again, you can click on and you can get information about the crash itself. We can also say, hey, I wonder how many collisions have happened where a bicycle was involved, and just immediate click there, and we've filtered down to the bicycle involved crashes. Or another really common one are the alcohol related crashes. So for instance, there's so many stacked up right here. That might be a case where they need to go and see what establishments are over serving people. Wouldn't be the traffic people doing that, but they work together with the other agencies. I had mentioned, oh, actually, let me show you something else we can do. So if we have, we'll say alcohol-related crashes, and we want to study those crashes, we can just draw a square rectangle, however you draw it. And you can see I've selected 8 crashes all at once. And then we can come down here in this data grid and we can see more information about each of those 8 crashes. So these are some of the attributes that they're checking on. Remember, we filtered by alcohol involved, so those are all set to yes. But and we can see that there was a fatality right there, unfortunately. So we're able to really quickly, in the map interface, zoom to an area and select a bunch of crashes just very, very quickly. Let me turn those off and I will turn the roads on. So I was talking about the predictive modeling, and we were talking about some treatments or improvements they can make to the road to improve safety. So right now I've turned on all of the roads, but I also can turn on, scoot this over so I can see it. I'm on a small screen today. I can also turn on a treatments layer. So I'll come down here to my segment treatments and I will say, I want to see areas where treatments have been proposed. So for some reason, whatever the reason may be, this section of this route has been deemed an area that needs to be looked at further and have some safety improvements made. So there's a whole separate app that handles all of that. But on this map interface, you can select that there and they can see, okay, they're going to add striping and an edge line to this segment of road to improve safety. And you can see some of the scoring in here. That's probably getting pretty technical, so I'll skip that. But I'll just say that, yeah, you can really quickly get views of filters and queries really rapidly. Let me show you some intersections. So if I hit that, we're going to turn on all of the intersections. And I can say, okay, there's all of the intersections, but I'm only interested in seeing the ones that have fatal crashes associated to them. And I can just zoom out and citywide see every intersection that's had a fatal crash. And so what that does is gives the engineer it just flags it for them really quickly. Okay, I need to go in here and I need to take a look at this specific intersection and see if there's something we can do to reduce the propensity to have a fatal crash there again.
So, Kristi, I think we're running down on time too, so we're gonna get you
Well,
move on to the other ones.
Yep, thank you. So those are some predefined queries. Now I'm over here in our rapid mapper. And so these, I think there's a question that popped up there. I'm going to keep going here.
Okay.
So here we're going to set some filters on the fly. So I'm going to say I want to look at all of the crashes in every county except for Park County, which is where Yellowstone is. And then we're going to see we've returned 140,378 records just very, very quickly. And then you'll also notice here that we have a series of graphs and charts that provide additional information. They'll say, okay, well, I want to see all of the crashes that didn't occur in Yellowstone that occurred in the month of, we'll say June, since we're in June. Got some type ahead here. And you'll see this number drop down. And now we're down to 10,000 crashes. And you saw that all of these charts here adjusted on the fly. I'm going to come back over here. And real quick, I will show you the new faceted search. So, I had something turned on already. So these are some, we call them emphasis areas or safety emphasis areas. These are things that engineers want to know about, and traffic safety studies are concerned with things like alcohol involved crashes, drugs, etc. So people are really used to shopping this way and filtering. I mean, we do it on Amazon and any online stores where you're able to go over to the side and sort of filter down into the categories and see only the things that you're interested in. So we have been able to tie in this faceted search with a rapid display on a map, and we're pretty impressed with that and hope that you are too. So yeah, we can say, oh, we only want to see alcohol involved crashes and alcohol involved crashes that were a hit and run, and immediately it'll filter down. And these are all the routes in the whole state, and then just those crashes that involved alcohol and hit and run. I think I'm probably about out of time.
So I wanted to mention that some of the things that we're showing you today, we're going to actually go into more detail in an Ask Tom session later in the summer on actually how to do it yourself. So we're going to try and facilitate others being able to do some of these things. I think you'll see like this faceted search is it's pretty amazing. The types of displays you can quickly render and how effective it is in drilling down to the areas that are most important. And we're going to do the same thing with the smart filters approach too as well. And we'll plan on doing more of that in the Ask Tom session. The date, oh, there it is. On July. So
we've got a question from Sam Armani. Does Spatial Studio offer tools for visualization, 1D KDE hotspot analysis along linear features such as roads? That probably means more to you than me.
Yeah, let me look at that.
I mean, that's
a type in an answer, Gary, too.
Oh, great. Well, first of all, I'm not sure what the 1D KDE
so that's like one-dimensional density along like kernel density along a linear element. So actually, I'll just sort of answer verbally. So that's not a built-in feature in Spatial Studio. It would be something that you could do. You could do like separately from Spatial Studio, for example, just do that in Python and where you're connected to the database and label do the labeling using a suitable library and just persist the results in the database, and then Spatial Studio and the whole safety portal and everything picks up the results. I'm answering that in that general way because we do actually have, as of very recently, a set of spatial ML features for autonomous database that includes clustering, but more like 2D clustering, DB scan, k-means clustering, and not specifically the 1D kernel clustering you're talking about. So the short answer is no, it's not in Spatial Studio, but the good thing is it's really easy to work with, the libraries that have that, connect to the database, label the data, and then it just gets picked up again by Studio, the safety portal, APEX, whatever you wanted to do with it. So Jerry, that was sort of a very generic, Oracle technology answer, but if you wanted to, if that's something you wanted to speak about from the ITIS perspective, that's fine too.
Well, I think you generally answered just fine. Is that the nice thing about what we have here is that there's a great out of the box kind of toolbox to use, but it's very easy for us to interface other tools with it as the need demands.
We have about 5 minutes left, so if anybody has any questions, please go ahead and enter them into the Q&A section, and we'll get them answered as quickly as possible. Or if you're a little shy, you can always email questions to Kristi and Gerald and David.
Yeah, thanks so much for joining us today.
Yeah, we certainly appreciate your attendance today. And if you're interested in these kinds of things, please let us know.
Hey, Jerry, maybe I'll ask a question if that's all right. Mm-hmm. Actually, it looks like there was a question that just came in that, okay, yeah, recording and slides.
Will the slides and recording be made available? Yes, there are going to be two things here. They're going to be published on the Oracle, the Analytics and Data Oracle User Community website in our TechCast section. And then they're also going to be posted on YouTube.
And there's another question that just came in, Jerry, for you guys. Looks like.
So on safety factor, that's not a term that we use. We create a safety score based on. So we use the Highway Safety Manual method for doing the predictive crashes. We come up with we calculate that for every 10th mile section for the entire road network, and then we have a scoring mechanism that scores all of the segments, both in entirety, just from a count, or by severity types, and we use that to categorize various segments of roadway. So safety factor is not a term that we're using, but it's probably the scoring that we do is somewhere equivalent to that.
Maybe crash factors.
So it looks like there's maybe a minute left, and just if any other questions come in, I'm sure you'll jump on them. But one thing maybe folks are wondering, Jerry and Kristi, is this is obviously very robust and sophisticated traffic safety solution, and all the ways that you're using the technology, fit in so nicely. And as far as ITIS goes, this is obviously your wheelhouse, but are you guys actually involved in sort of solutions that extend beyond road safety, just out of curiosity?
Oh, absolutely. I mean, we love spatial to begin with. So anytime we want to integrate database and spatial, any kind of business application where visualizing some kind of resource on a map is helpful, that's stuff we think we're pretty good at, especially if it's based on Oracle Stack. Yeah, we love working with the tool set, and maps are sexy. People love working with maps, and we really like adding those to business applications, and so yeah, we get asked to do that kind of stuff all the time.
Well, we're right at the top of the hour. Let's give a big hand of applause to Gerald, Kristi, and David. Thank you very much for your presentation today. Thanks for your participation. check us out in the future for more TechCasts, and have a great day.
Thank you.
Thank
Bye,
you.
everyone.
Thank you.